Hey guys, welcome back to another episode of Simulators. Today's going to be an absolutely fantastic day where we talk about stuff again. If you weren't here yesterday, we finished up the determinate visualization. Here is a quick example of what it looks like. So let's do mplayer out.mp4 mp4. Let's do, what do I want to do? vox11 and loop 0. Okay. So if we watch this visualization, it's basically exactly what we want. We show the transformation of one box into another, we show the original box, and then we show the exterior box, and we perform the Monte Carlo integration. Now, that said, we're going to need a lot more particles in the end, and they need to be a lot smaller, and we also want the particles to be way less visible so that, for example, at the very end here, we can actually see the internal box. But that said, I think it looks pretty dang good. I'm pretty excited with how this visualization turned out. And I'm pretty excited that in the end, we got exactly what we needed, which was a ratio of the areas of exactly 9, which was a determinant of this particular system. So we can appropriately visualize determinants, and I think that's absolutely brilliant. I'm pretty excited about that one, guys. Okay, so what are we going to do today? Well, today we're going to take a step back, and we're going to talk about Huffman trees. Now, we've been doing this before, and we did it before working on the determinant visualization. Then I took 3 days off to work on the determinant stuff, because I think that'll be the next YouTube video. And then we're going to come back to the Huffman stuff. Now, when we last left the Huffman stuff, we were significantly far along. And the reason I wanted to save this for a weekend is because it's going to be a lot of drawing with code today, and a little bit of actual computer science. So that said, keep that in mind. There's just a whole bunch of little tweaks we have to do to the code to make it look just a little bit better here and there, and we need to figure out exactly how to do that, and I'm not sure exactly what to do with that right now. So let's go ahead and open up Zernal, and let's talk about what Huffman encoding is. And for the record, guys, if you have any questions, comments, concerns, let me know, and I will totally get to those as soon as I see them in chat. Also, let me get a quick sip of water. I'm thirsty. I usually wait till later to get water, but I'm super thirsty. Okay. Also, I got my window kind of open today again. I mean, it was nice yesterday. Coding with the ocean right there. That was pretty good. Okay, so let's go ahead and get started. What is Huffman encoding? Wait, where's my pen? There it is. What is Huffman encoding? Okay, well, Huffman encoding is essentially a way to take a string and put it into a bunch of bits. Okay, that's the idea. We are encoding the string into a bunch of bits, and this allows us to have a stable method to encode and decode. How does it work? Well, let's say we have a string, A, B, C, D. That's our string, and we want to encode it into bits. We'll put A, B, C, D with the frequency in which they appear, so 0.25, 0.25, 0.25, 0.25, and we add together the two lowest first, 0.5, then the two lowest value again, 0.5, then the two lowest value again, 1. Then we say 1, 0, 1, 0, 1, 0, and we read backwards. So for example, A is going to be 1, 1. B is going to be 1, 0. C is going to be 0, 1. And D is going to be 0, 0. So that means that this is encoded into 1, 1, 1, 0, 0, 1, 0, 0, 0. And that is the encoding phrase. And obviously we can decode pretty easily. We know that A is 1, 1, so this decodes into A, B, C, D. And there you have it. A, B, C, D. Okay, page. New page before. Now this can obviously get more and more complicated. The more complicated we want to make it, we can encode incredibly arbitrary phrases. And we can make this thing be, well, I don't know, a little bit difficult. Which is what we've done in one of the previous simulations of this. I guess, is this a simulation? I don't know if it's considered a simulation or not, because this is actually what they use for computer science stuff, right? So maybe it's not so much a simulation as it is actually just a method, but I'm going to call it a simulation because I call everything a simulation. So if you guys have a problem with that, let me know. It's okay. Anyway, so what can we do with this? Well, first things first, the original iteration of Huffman encoding dealt only with percentages. It only cared about the frequency at which A, B, C, D, and E came in. So for example, if A came in with a percentage of 70%, B came in with a frequency of, let's say, 0.15%. Here, let's write them all the same. 0.15%. C came in with a frequency of 0.05%, and let's say 10%. And D came in with a frequency of 0.5%. Yeah, that adds up to 70. Then what we do is we add these guys together, 0.15. These guys together to 0.30. These guys together for 1. We do the same thing we did before. And now you see we have a completely different encoding scheme. A is now 1. Gosh darn it, I have something in my eye and it is bothering me. A is 1. B is 0, 1. C is 0, 0, 1. And D is 0, 0, 0, 1. And this is, in a way, still 100% optimal, because A appears so much more frequently than B, C, or D, it makes a lot of sense to have fewer bits for A and B than it does for C and D. And that's exactly the point here, right? We've got a whole bunch of, we're trying to encode the bits by using the least number of bits, and the Huffman encoding scheme allows us to do this. So what are we exactly working on today? Well, today we're working on the visualization of this. And now I know what you're thinking. It seems pretty easy. It seems pretty, pretty visual already. And you're totally right. However, we want to move on to the next step, which is dynamic Huffman encoding. And dynamic Huffman encoding is not exactly easy to understand, because here's the idea, right? So dynamic Huffman encoding, let's say we're encoding the phrase hello. In some sense, it is easy, right? We start with nothing. Hey, Zivo25, what's up? In some sense, it is easy, right? We start with an H, and H has a frequency of 1, so H is originally coded as, let's say, a 1 or something like that. Super simple tree, H, 1, 1. Okay, now there's an H and an E, both show up with the same percentage, then you have them adding up to 1, 1, 0. So HE is going to be 1, 0. Now you have an L, so the next one is going to be HEL, and this is going to be a frequency of, let's add these guys together, then these guys together, so it's going to be a frequency of 1, 0. So now you have a couple of guys that are encoded with 2 bits. Now if we keep going, you'll see that we have 2 L's, so we put the L's at the top, so L, and I'm going to write L's like this, L, H, E. Now these guys have 2 bits. And you see that as we start doing the dynamic Huffman encoding, what we're basically doing is we're changing the tree every single time step so that it fits the appropriate characters that we have read so far. And this means that if we have a super long string, yes, Huffman encoding, exactly. If we have a super long string, it ends up being that with this super long string, we can actually encode every single bit. How do I put this? We can encode it such that it is optimal for every bit that we have so far. And that's pretty cool. So what we're going to be working on now is making it so we can visualize a single Huffman tree. And then after visualizing that single Huffman tree, we're going to start moving on to dynamic Huffman encoding. Now, here's the thing. I want to get started with dynamic Huffman encoding on Monday. So if we get done with this early, which we might because we've got a good bit of this done already, in that case, I'm going to do a side project tomorrow, and then we'll get started on the dynamic Huffman encoding and stuff like that. That's fine. Unfortunately, Zivo, we're almost done with the Huffman encoding stuff, but talking about it early. Wait, how do I put this? I start out with a quick discussion of it for the first 10 or 15 minutes, and then I do the actual coding after that. So if you have further questions, let me know, and I'll totally get to those when I see them. But again, Huffman encoding is pretty simple, right? Just to recap, new page before, you take all the frequencies, 0.7 of all of the different characters. So let's say we have something like this. 0.7 for A, B is going to be let's change 0.6. Then we do B as 0.1, C as 0.1, D as 0.1. Hey, guess one. E as 0.1. We add these guys together to be 0.2. These guys together to be 0.2. These guys together to be 0.4. These guys together to be 1. And then we just go back. 1, 0, 1, 0, 1, 0, 1, 0. And A in this case is 1. B is 0, 1, 1. C is 0, 1, 0. D is 0, 0, 1. And E is 0, 0, 0. There you have it. You've encoded a Huffman tree. Now, we just did this a second ago. So let's get back to how we did the visualization. I'm pretty excited actually with how the visualization turned out as of the last time we looked at it. Now let's see what it looks like now after we took us some time off and looked at some other stuff. So for now I'm going to go ahead and move on to the visualization, and then we'll take a second to see what we need to do. So let's pop over here and let's CD into, I believe it is Huffman here. Nope, it is Huffman there. CD projects, Simuleos, Huffman. Okay, so what are we going to do? Let's go through and let's look at what we have so far. LS, we have in frames the visualizations. Let's open up Mirage, frames, then what do we want? We want animation.gif. Okay, so as you can see, we can generate a whole bunch of little dots, and each of these dots have characters on them, right? Then we can draw the Huffman tree, and the Huffman tree is drawn correctly. All the dots are drawn correctly. The one thing I don't like is the fact that all of the white lines go over all of the green leaves. And that's something we need to fix. So again, I'm going to get some water and then we'll keep going after that point. Gosh, I'm just super thirsty today. Okay. Now, let's go into the actual code. Those leaves, yeah, they definitely need more spacing. And yeah, we are using Cairo for this. Okay, so let's do ls. Let's go into vi Huffman .cpp. Oh, okay. So we can definitely give the leaves a little bit more spacing. That's perfectly fine. In fact, let's just do that now. Here's what we're gonna do. If we give them a little bit more in the X direction, what are we doing? This is where we create the initial nodes. So let's go down to main. Here we are. And let's see, instead of giving it, what was I giving it? I think 400 by 300. Let's see, initial weights, Q, string. 1 second, where's the init command? Oh, that's because this is the wrong file, my bad. This would be vi Huffman visualization.cpp. Now let's go down to main. There we are. Okay, so frame animation, we give it 400 by 300. If we increase this to something a lot larger, let's say 600, we should see more spacing with the leaves. So let's do this, and let's run the make command. It's been a few days since I worked on this, so forgive me if I'm a little bit rusty with it, but I think this should be okay. Now it's putting it all into an animation, and let's see what it looks like. 1 second. Takes a little bit of time to convert it, but that's okay. I think it's probably worth it. Okay, so now let's do Mirage animation.gif. Okay, so now the leaves have a little bit more spacing. Not so much more, but a little bit. I guess we'd have to, let me think. Yeah, let's go ahead and increase this to 800. And let's increase this to 600. Let's go over here, let's do it one more time, and let's see what happens. Okay, so obviously there are a few things that we need to do with this particular drawing scheme, right? So one thing we could do, which was suggested by, I don't remember who, but someone suggested it the other day, is we implement layers in our system. And that's something we have not done to this point. So we need to think about how to do that if we want to do it at all. And these layers would allow us to draw the leaves on a different layer as we draw the lines. And this would mean that we could potentially have all the leaves drawn at a separate place. Yes. Yeah, I guess we'll see what happens if we do that then. So let's try, what would the final resolution be? The final resolution would be I don't know. What resolution is my screen? Let's just do... Wait, what is the resolution of my screen? 1 second. It is 1920 by 1080. Let's see what happens if I do that. 1920 by 1080. Okay, and I don't remember what this 10 means. Yeah, I don't remember what that means. So let's go ahead and write this. Let's go here and let's do make. It's going to take a little bit of time, but that's okay. Yep, give it a second. FHD, yeah, that's exactly what we got. Thanks. No, it's okay. You got it. I didn't look at chat anyway, so I apologize for that one. Okay. Give it a second to make all the images. Now, here's the thing. There has to be a better solution. I'm going to go ahead and point out all the problems that we have with the animation so far in just a second. So once it puts it all into an image, we can then talk about what all the problems are and then go from there. Because again, in a sense, we want this to be kind of a visually stunning animation that really gets people pumped about doing Huffman encoding and stuff like that. So we've got a lot left to do to make this get to that point. And I have plenty of ideas on how we want to get from where we are now to where we need to go. One of which is obviously finding a dynamic way to show the letters in which we're encoding and stuff like that. Also, about your project idea thing yesterday, if you're interested in small programming puzzles, check out Daily Programmer. Oh yeah, that's a good idea. Daily Programmer is great. Okay, this is taking a while because all the images are huge. Give it just a second to make the animation. I've got a feeling that when we actually pull up the animation, it's not going to really make a GIF because the GIF is going to be really, really large. I probably should have turned it into an MP4 file, but that's okay. We'll see how long this takes. Anyway, things that we need to do. If you remember from before, the last image, the white lines go over the green lines. I don't like that. Another thing we need to do is something that Gusturn mentioned, which was... Okay, let's see. Does this actually play? It's not going to, is it? That's okay. Oh, that was not what I meant to do. Oh, is it playing? Oh, it is playing. Wow. Let's make it big. Okay. So here's all of our dots. Yes. Okay. So even with the highest resolution possible, we still run into a bit of a situation where I'm not sure what I'm doing. Oh. I guess let's scroll down. No. Oh, okay. So here's the final tree. I'm at 196 or something like that. So this is the final tree. Even with the highest tree possible, we still see a problem where some of the dots overlay each other. And that's a bit of a pain. So what we need to do is fix that. We also need to fix the problem where some of these lines interact with each other. So for example, we have a green leaf here, and there's a white line going right over the green leaf, and that's a bit of a pain. And there's a few other things we need to do here because of how these things are being created and stuff like that. So we have to think about unique ways in which we can go and fix these small graphical problems. Which is kind of why... Oh, sorry for the yawn, guys. Which is kind of why I decided to leave this until later. So that's why, in the end, I decided to do the determinant video first, because this stuff does not come intuitively to me. Meanwhile, the determinant stuff, that's pretty easy and fun. So I thought it was pretty good to do. You should start the current ones. You actually got replies from posting your solution. Oh, okay, I see. Yeah, sure, the Daily Programmer. Okay, so let's go and let's change this back to 400 by 300. That way we can have a nice little GIF running on the side. So if anyone has any questions, we can worry about that then. Okay, so let's run make one more time. It'll make the animation, and then we'll go from there. And this will take significantly less time than the last one. Okay, so once it's up, let's go ahead and start working on the problems. So the first problem is implementing layers. So let's do mirage_animation.gif. Yeah, Gusturn's great. He's super useful and helpful and everything. So, okay. So here's what we got so far. Lots of things to fix. Okay. So first thing we need to do is implement some sort of layer scheme. Now here's the thing. I I don't know how to do this exactly. So I'm going to try something and hopefully it will work out. That's about what we got right now. So right now we have a whole bunch of different frames in our big frame struct. What we need also is with each of these frames, let me see, we have int current frame, Kairos source key frame surface number of frames. I guess we also need a number of layers in each of these contexts. And that's something I'm not really sure I can figure out how to do. Let me Google this real quick because I failed to Google this before. Let me see, layers, Cairo, C++. Maybe there is an easy way to do it. Let me see, Cairo, tutorial, 3 layers in the diagrams. Maybe it's just something I didn't think about. Layers. Yeah, they mean something else when they say layers, which is fine. Okay, so here's what we're going to do. A while ago, we made this program that was meant to create like a webcomic of sorts. What I'm going to do is I'm going to go back there and I'm going to implement layers there. And we're going to see how far we get with this. So give me a second. I realize we are still kind of doing the Huffman Forests thing, which is, again, the name of the stream today. But we need to take some time to figure out how to draw these layers and do things a little bit differently. So I'm going to take a second step back and let's work on that. So I'm going to cd back a couple directories into the subroutine webcomic. Let's do that. Oh, what was I doing there? Quit. cd into subroutine webcomic. And if you guys are not familiar, this webcomic was basically a way for us to, well, draw a webcomic. This is our first ever experience with Cairo. So if we open up Mirage, subroutine.png, you'll see, hey, look at that. We have an image that is literally some guy saying hello world. Took us a while to get there, but that's okay. So now what we want to do is implement layers. So I guess what I'll do with this image is I will go forward and I will add in a layer on top of this image, right? So let's try that. So let's go into VI. I think it's subroutine.cpp. And let's see what we got. So we have class panel, and in the panel class, if Arches Convert has a WebP support, you should probably use that instead of GIFs. I don't know what a .webp file is. Sorry about that. Okay, so we have int box height, Cairo surface t panel surface, Cairo t panel context. Now, how do we want to do this? For every one of the contexts, which is its own panel in the comic, for the record, when we say panel, we basically mean this. So because it's a webcomic, instead of doing frames like we did afterwards, let's say we want, I don't know, 9. And then let's do make. Okay. Mirage subroutine. We basically made it so we can make a whole bunch of different panels. And that's where we were at. So let's go here. And of course, that still broke, but that's okay. Okay, so let's go back here and make it one more time. And let's open it up. Okay, so now we just have to do layers. Okay, so what do we need to do? For every single one of these contexts, where each context is its own panel, and then all of the panels are written to one surface, we now need to create an additional, what I'm just going to say is additional layer. Okay, what I've never heard of WebP before. I guess it's because I'm on Reddit all the time, and I literally only hear of graphics interchange format files. But anyway, we'll see. I'll take a look into that after stream. Actually, let me write it down real quick so I don't forget. WebP instead of GIF. Okay, so let's see what we got. Hello world, that works fine. So now we have to worry about layers. For the layers, I'm just going to implement a very stupid scheme right now. So here's what I'm going to do. I'm going to say Cairo T. And I'm going to say layer. Yep. So what I'm going to do. And I'm going to make it of size. Let me think. Man, I feel like I need it within every panel context. Like every panel context should also have a layer, right? So each of the panels, or in the next case, each of the frames, should also have a layer associated with it. So what we have here, let me see, panel context. Let me think. Cover sheet layers. So here's what we want. Layers, I guess I'll just make it a size 1 for now. Yeah, maybe a size 1. Okay. Now let's go down here and let's see what we got. So we have write all, create scene. We have layers of 1. Yeah, that's not going to work. We need some way to put it within each of the panel contexts, which I failed to do. I thought this would be super easy, so I didn't really think about doing this last night, but now I'm looking at it and I'm thinking maybe this wasn't as easy as I thought. Okay, so what do we need? Surface. First of all I need to get from this is how to write the image. So let's go down to writing the image. Okay, comic subroutine dot, here it is, write image. Okay, so we say for size t, I equals 0, less than the number of panels I plus plus. We set the source surface, comic background context, panel surface, then we give it an x and y position, and then we paint it on there. Okay, so what we need to do then for the, what if we create an external cover for all of the different layers? So what we need to do is, instead of doing, here, let's try this. So what we want is a vector of panels, and the vector of panels will be our layers, right? So each panel will have its own layer, and it will be within the layers. So we'd have like layer 1, layer 2, layer 3, and it'd be layer 3 of panel 1, so on and so forth. Maybe that idea would work. So let's go here. Let's see, we have class people. How do we do this? So let's go down to our main function and let's see what we have. Again, this is a lot messier than the main function on the other, on the Huffman stuff, which we'll be getting back to probably in about 30 minutes. So we have panel comic.box height equals 2000, box width equals 2000, gap equals 10, length width equals 5, line width equals 5. Sorry about that. We create the scene. Then we do vector of doubles, x5. Okay, so what do we do in create scene? That's the question. Create scene. Here it is. Oh, we do a lot of stuff in create scene. Wow, that's a pretty big... Oh, I see. Create scene is the one that gives us the appropriate number of panels and things like this. This actually might be even more complicated to work with than the Huffman example that we were working with before, but that's okay. So what we need to do then is create scene, and in this scene we read in a panel comic. So all we'd have to do here is basically read in each of the individual layers and change the write image command. This isn't so bad. So I think instead of working on this directly, unless you guys are super sad for me not to work on this directly, I think I'm going to work directly on the Huffman stuff, but we used this in order to understand how to get to the Huffman stuff. So I realized, yeah, it's 30 minutes in, we haven't done any coding yet. That's fine. It's kind of a reconnaissance day. We're learning how to do this. So let's go ahead and right quit here. Let's go ahead and close this. I just feel kind of bad because if I've spent all day working in the subroutine webcomic and it says Huffman Forests on the title, I'm not really doing Huffman Forests. You know what I mean? So let's cd back into Simuleos Huffman, and let's do this, cd back Simuleos Huffman. Okay, so now I think we have an idea of how to implement these layers. So what do we need to do? Let's go ahead and open up the graphics interchange format file one more time. So it's going to be Mirage. Oh, of course that's not going to work. It's going to be the last Mirage, which is not there. This one. Okay, this is what we got so far. Now let's go into VI Huffman visualization dot Huffman visualization. There we are, .cpp. Okay. And this is what we got. So we have number of frames 200. That's okay. We have struct frame. That is also fine. And let's see what we need. Frame animation is going to be frame that. Good. So what we're going to do is we're going to say the following. Hey, didclosm. And I don't know how this is going to work. Hopefully it works okay. Maybe it doesn't work at all. We'll see. So we're going to do std vector of, what do we want? We want enum. No, we want frame. Okay, and we're going to say layer. And how big do we want this? We want it maybe 3 big for now. So that's going to be a background layer, an intermediate layer. So basically a layer to put the black background, a layer to put all of the leaves, and a layer to put all of the lines. So we'll do this, and then we say for int I guess size ti, I equals 0, I less than layer dot size, then I plus plus. Plus plus I guess it doesn't really matter. I. Gosh darn it. Let's go down here. And there. So now we have to change all the anims to the appropriate layer. So, good. Good. So all of these guys are now layer of I. Change this to layer of I. And down here, layer of I. Okay, now let's just very quickly make sure this works. We're not even going to move any further than this. We're removing all of this Huffman encoding stuff for now. In fact, yeah, well actually we could leave a lot of this. Everything except for draw internal and external. So let's go ahead and write this. Go over here and let's run the make command. So let me see, what do we have? Error, no matching function for frame. Let me see. Frame. Candidate, frame, int. What's the issue? 1 second, let me go to 188. Frame. What? Let me see. 75. I did something stupid here. No matching function for call to frame. No, candidate frame. What? 92? Okay. Oh, vector of... It is called frame, isn't it? Yeah, vector of struct frame. My question is why it doesn't like this. Let me see. Do I need to do this? Anim was not declared in the scope. Error expected semicolon. Okay, maybe that's right. Probably not, though. Error. Expected primary expression before... Oh, yeah, so let's go to 95. Okay, I'm going to assume that works. I'm not sure, though. I less than this, and then we'll do anim. Where's anim? Where's this? 133? Here. Node Q. Let's see, anim. So what we actually want, regenerated nodes equals regenerated nodes. Let's remove this, and let's see what we got. Make it one more time. Let's see, 134. Oh, obviously. I should have figured that one. Okay, so now we're gonna make it. Error 1, Huffman visualization. Let me see, what happened here? It looks like include undefined reference to frame. Dang. Let's see what we got. Let's go ahead and write quit. vi Huffman dot h struct node. Okay. So what it doesn't like, let me see. Makefile 14 recipe for Huffman visualization failed. SQL construct 75 frame. Okay, so let me do this. Huffman visualization at CVP. Let's call this frame init. I don't like this. Maybe create frame. Maybe that works. Let's try that. Let me see. 188, obviously. Okay, so we do create frame, create frame. Okay, let's go up here. Where are we? To main. Good. And let's change this to create frame. Make. Let's see, what do we have? ISO forbids declaration of create frame with no type. Obviously, let's go up to the struct. So it's going to be frame. Oh, I can't even spell frame. Let me just scroll up. So what do we want? We want this to be a void. Let's go to, actually, does this work? Not sure. Let me see. ISO forbids declaration of create frame with no type. Oh, let's go down to frame. Oh, sorry. Frame. Frame. Let's see if I can do this. There we go. Void frame in it. Oh, frame draw frames. We want this one. Make. Create frame was not declared in the scope. Oh, okay, so let's do it this way. Scroll to the top. Let's see, so we want frame layer of I. Then we want, how would I do this? Layer of I. Dot create frame, and this is fine, this should work. 1 second. It seems to be taking its time. Shouldn't take this long. I think it's, yeah, it's totally stuck on something. I don't know how it got a segmentation fault for that, because that seemed relatively straightforward. Okay, so let's see. Makefile recipe for target Huffman visualization failed. Segmentation fault. How the crap did you get a segmentation fault? Okay, let's change this to what it was before. So we're going to remove this line. This line. This line. Change this to anim. In fact, let's just do this. 1 second. Let's comment this whole guy out. And this guy out down here. And let's run that. Okay, so that one works just fine. I don't know what it's converting, so maybe we should go into the Makefile real quick and remove that. Okay, I've got a feeling today is going to be a little bit hard to follow, and I apologize for that. So if you have any questions, let me know, and I'll totally get to those questions as soon as I see them in chat. Basically, what we're doing now is we're trying to implement layers with the Huffman encoding scheme that we had before. And if you have seen the animation, then you'll know that it looks pretty good. But we need to implement layers to go a step further. So this is not something I've done before, and it's somehow not trivial. So let's go here and let's do the following. We're going to say frame anim. Then we're going to say anim.create frame. And we're going to grab all of these arguments here. Then we do anim.init, where we read in 0, 0, 0. And then finally, anim.currentFrame equals 1. Add in a semicolon at the end here. Write this, go over here to, not the Makefile there, make. What algorithm do I use to generate the layout of the tree? I don't know what you mean. I don't know what you mean. We just kind of made stuff up. So for the, let me do, one second. Mirage animation, frames animation.gif. Let's see. Oh, of course it doesn't work. Let's go down here. Where is the rest of the main function? Draw external. Okay. So let's go ahead and create a new animation. And then I'll show you what I mean. So let's go into the Makefile. Move this. And let's do make. Yeah, I know what you mean, Gustorn, but let me show you the animation, and then I'll show you what we did in just a second, so that you can kind of see along as we do it. Now we want these commented out. Yeah, I totally get the question, but 1 second, let me show you. I didn't use an algorithm for that. I mean, it kind of made intuitive sense for where things needed to be. So let's do Mirage animation. Sorry, frames animation.gif. Okay, so you'll see that all the leaves have a different position. The leaves were actually the easy part. The internal nodes were the hard part. But we have two different functions here, which are draw external and draw internal. So let me go to draw external first, which is the leaves. So draw external here, there, and here. Okay, so draw external, basically what we do is we fit it inside of the screen itself. And I'll admit this isn't the easiest way to conceive of this. But basically we have the lowest location on the grid, which is going to be log 10 of 1.0 divided by tree.root weight. So the idea is we take the root weight, which is the entire weight, and we say that's going to be the lowest location on the grid. Or in this case, highest location. Then we go through the entire tree itself, and we say, okay, well, the new position is going to be equal to its weight divided by that weight, right? So that's the lowest position. So we normalize it in a way. And then we divide that by the lowest location. So the idea is that we kind of put it on some scale between one weight and another weight. And we say if it's super low, it's down here at the bottom. If it's super high, we're up there at the top. So only the root node will be at the top. All other nodes will be at the bottom. Because again, all the weights have to add up to the root node, right? So in the end, all we have to do is kind of divide the weight, whatever weight we're at, by the weight of the root node. And then we get some sort of location in Y. The Y location wasn't so bad. The X location was a little bit challenging. So for find X position, which is what we use for both of them, we basically took the tree and we split it up. So we read in the bit string, which is obviously the zeros and ones and stuff like that. And we said, okay, we're going to go through and we're going to give you a position based on this string. So the idea is that we start at 0.5, and then we say if you're a 1, we move to the right. If you're a 0, we move to the left. And we move to the right 0.25. Now we're at 0.75, let's say, if we got a 1. Then we say, okay, well, now we're going to move to the right or left if we have a 1 or a 0, right? And so then the question is, how far do we move? And that's going to be 0.125, right? And then the next one's going to be 0.6. 125, and the next one's going to be 0.3 something, so on and so forth. So basically the idea is that we start at 0.5 and then we move back and forth to where it's supposed to be, so that we make sure that all of the leaves are positioned with Y according to their weight with respect to the weight of the root node, and in X with respect to their actual location for encoding. So we move it to the right or left, depending on how many ones and zeros are in the final encoding scheme. So that's the idea. Now, we've got... What I would like to do first is implement the layer thing, and then go back to implement the a new location for all the leaves. Because the X ones, basically all we have to do is find a way to stretch it along X, which isn't so bad, but we have to think of how we want to do it. I didn't think there were any regular tree layouting algorithms. Is there such a thing? If there is, I apologize because I didn't think about looking at it. I thought this would be, kind of intuitively simple and make a good bit of sense in terms of readability and stuff like that. But we'll see. Anyway, what do we need to do? We need to figure out why this layer thing isn't working. And I actually have no idea why it's not working. So we created, let's see, what do we have here? We created a vector of frames, which in my opinion should work. We called it layer. We gave it 3 initial, here, let's go down here and let's see. So we have anim. Now let's see if we can figure out this layer thing. So let's do this. Let's say std cout I end line. Let's see what we're doing here. Let's go over here and let's make it. Actually, did I remember to write? Not sure. Make. Let's see. Okay, so that's definitely going too high. Let's see, what do we have? What's the problem? In the beginning there was Newth. Oh, I see. Okay, fair enough. Maybe I should look into some of these. New thread. Yeah, maybe I should look into some of those. Alright, see you in a bit, Zivo. Okay. Draw tree. Okay, fine. I should look into some of these. I apologize for that. Okay. From the bottom up. Okay. Well, I'll look into some of those later. Right now we have to figure out how this layer thing, or why this layer thing is not working. So let me do this. I'm going to SDC out something at the start here. And then comment this guy out. So let's go here and let's say std cout layer dot size. We initialized it as a size of 3, so you'd think that this would work, right? Let's go to make. Let me see. Final tree. 3. It is a size 3. So somehow we are creating new frames every time. So let me see this. Create frame. Let's see. Void create frame. Int x, int y. Okay, so one thing I just did, which was really, really stupid of me. Let's go down to the bottom here. And let's see what we got. So what I need to do is not remove those lines, but remove this line here. I accidentally wrote over the animation one more time. So I need to redo the animation. And let's go from there. Cairo doesn't have layers, so we have to implement it ourselves, which is fine. We just have to know to do it. So let me remake the animation, and then we'll kind of keep that up on the side as we try to figure out what we need to do with this layer stuff. So that's kind of the problem, right? So we're using a super minimalistic system. So we don't actually need layers for this simulation. What we could do is just continually redraw each of the points at their appropriate location, and that's fine. That is totally one way to do it. But I think the layer one would be a more elegant solution in the end. I just have to kind of think about how to do it. So let's do this. Kind of keep this up on the side. Yep, seems to be working okay. Now let's go into the make file. And let's go ahead and remove this guy, because we won't be needing it for a bit. Okay. Now, let me go up here and let's see. I'm going to need to comment these guys out again. And comment this guy out. And this guy out. Okay, so now let's see what we need to do. Let's go up here. And why is create frame? Okay, let's go down to create frame. Here it is. We say resolution X equals X, resolution Y equals Y. It doesn't look like, yeah, it doesn't look like we at all create a new, like, why would I be adding something? You know what I'm saying? Like, I never push back the size of that vector. So for some reason it goes from a size 3 to like some infinite size. It just keeps growing in size. I'm not sure why. So let's see, origin, PNG base, create frame. Okay, so I'm not sure what's going on here. So let me try something else then. Let me try removing this, and instead of saying layer.size, because for some reason that increases, let's change this just to 3. And then let's go down here and say std cout layer dot size. And then let's do end line. I think I realize now what I just did. So let me go over here. Let me run make. Layer dot size. Layer, it does not exist. Let me see. Layer dot size. Oh, that's because I did not initialize it. Let's go here. Make. Give it a second to do the making. There we go. It says segmentation fault. Crap. Let me go up here. STD. Cout. Layer. Oh, no, we already did. It is a size 3. And then it is a size through this. I don't know how it got to that, but somehow it is of size that. 386931704960736936934. Crap. Why would it do that? I'm not sure. So I guess we'll say frame layer. Oh, maybe it's because we do this. Maybe if we do this, make. Let me see. Okay, this one actually worked. Okay, good. So it's because we were redefining each layer individually as a frame. So if we go here and we say layer.size, I think we should be good to go. Make. Good. Okay. So it was because within the loop we were defining each layer as a individual. All right, Zivo, that's okay. I will see you around. Have a fantastic day, night, evening, whatever time it has to be your time. And I'm streaming until 7 o'clock in the morning my time, so that's about another hour and 10 minutes. So if you come back before then, that's great. If not, have a good day. See you around. Okay, so we're creating the frame each time here. We have layers.size. Everything seems to be good for me. Okay, so now we have all these different layers. Now, let's go through and let's work with this. So now, instead of reading in for draw internal and external, instead of reading in, what do we want to do? Frame anim. Yes, okay. So I want to read in the layer at which I want to work on for draw internal and draw external. But I've got a feeling that I don't actually need to, worry about, how do I put this? I think I can just read in the layers themselves. So let's see what happens. So we find X position. That should be fine. Draw external should need changing. Regenerate nodes. What do we use anim for regenerate nodes? There we are. There we are. Regenerate nodes. Performs depth first search. Do we use anim? It doesn't look like we use anim for this. I don't know why we're reading it in. Regenerate nodes. Perform depth first search. Oh, we need it for depth first search. Okay, let's go there. Depth. First. Okay. Next. Here. Okay, so what do we need anim for? We need anim for bitmap. 1 second. Anim. Next. Find X position. Okay, fair enough. So we need anim to figure out. Okay, that's fine. I'm okay with leaving anim in there. Okay, so that means let's go up here and let's just start working on this. So we're in main. 1 second. Where are we? We are not in main yet. Good. We are now in main. Now let's go through and work on this. So regenerate nodes is not going to use anim. Instead, it's going to use any arbitrary layer. So let's say layer of 0. And let's write this and see if this runs. I've got a feeling we're not going to run into any problems here. Yep. Okay. So now this is where we are going to run into some trouble. Let's just do this. Draw frames. And let's do anim. No, we want layer of 1 and layer of 2. Okay, so now this draw frames command is not going to work as anticipated. So what we need to do is an additional command called draw layers. And I could put this into a separate struct for layers, and that's fine. That might be something we do a little bit later, but for now, I think it's okay. So let's go down here and let's say function to draw layers. Okay, so now we're going to do void draw layers. And what we need is a std vector of frames layers. Good. So this should be all we need. Everything else should be held in the frame struct and stuff like that. Again, guys, if you've got questions, comments, concerns, let me know, and we'll go from there. What I'm going to do for now is I'm going to leave the animation up so you guys can see where we are currently at and where we want to go to. Good. I'm actually super excited with how this animation is turning out. It looks pretty good. You know, we're not there yet. We still have a little bit left to do, but it looks pretty good. And I'm happy that it looks pretty good, you know? Okay. Draw layers here. What else do we need to do? Good. Let's go down to draw layers. And also, let me first go down to draw frame. So we see how we did it in the frame struct. So let me go into frame. Here. Init. Draw frames. So what we did for draw frames is we went through each of the number of frames. And we went through and we said, we set the Cairo source surface from frame context I to frame surface I. So basically all we need to do is update this to, let me see, Cairo paint. Yeah, so here's what I'm going to try. I'm going to take this guy, I'm going to move it down to the bottom, and I think I called it draw layers. Let me go up to the top again. I called it draw layers, plural. So draw frames is going to be draw layers. And we're going to need std vector of layers. Good. Let's go here, draw all layers. Yeah, this is fine. Okay, so now what do we need to do? For size t, I equals 0, I less than number of frames, that should remain the same. Cairo set source surface, frame context, I, frame surface. Okay, this is where things start to get a little bit different. So what we need to do now is we're going through all the frames. Now we need an additional loop in here. I'm going to say for size t, j equals 0, j less than, I guess, layer dot size plus j. Okay. And I'm not sure how much we actually need to put in here. So let me go here and let's see what we need to do. The first thing we most obviously need to do is Cairo set source surface needs to be thrown into this. But I think Cairo paint, let me see. PNG ID. Okay, yes, so that's what we need to do. Let's move both of these guys into this here. Now let me add in a couple of spaces just for formatting's sake. Move this guy here. So we want frame context of I, but we also want layer of j. So we're going to do layer of j dot frame context of I. And I'm going to change this up a little bit. Let's do, it's fine. Layer of j dot frame context of I. Okay, so let's bring this down to the next line. We could have cleaned it up just a little bit by changing the looping structure, but that's okay. So after this, we then need to go through layer frame context. Let's see, string stream, frame context. Now what do I want here? Frame surface of I. How are we going to do this one? Frame surface of I. Where's frame surface? Frame surface is going to be the surface that we have in the frame struct, right? So what we need is a separate surface that we create here. So let me see, how do we do that? Set source, oh, frame surface of I, shoot. Okay, so let's create the surface here at the start. Wait, let me think. I think right now we're almost there. We just have to think about how to do this last bit. So frame surface of I. Okay, so let's go up to the top and let me see how we defined the frame surface. We defined it here. So let's see. I guess it doesn't matter in which layer we work with. So let's go down here. And let's say frame surface of I. So let's just say layer of 0, which is a background layer. Dot frame surface of I. And layer of 0, frame surface of I. Okay, this is kind of messy. This is kind of messy, but that's okay. So let's go here. And let's do make, and let's see where it breaks. First of all, it breaks on 506. Let's go here and add an additional colon. Let's try it again. Make. Okay, so now we have a whole bunch of other breaks. 50. Oh, sorry about that. Vector of layers 506 was not declared in this scope. That's because it should be a vector of frames. Okay. Next, layer was not declared in the scope. 509. For size T, layer. Let me see. Oh, that's because I didn't read it in. Layer. Okay. And then we have layer was not declared in the scope for the rest of them. So let's make it. PNG base. PNG base was not declared in the scope. That's because PNG base, I believe, is going to be in an individual layer. So let's go to layer of 0.png base. Let's go here and make it. Okay, this one actually seemed to do something. However, I'm not sure exactly what it did. Okay, so let's go into Mirage, frames, then we want to do image 00 whatever, .png. Okay, well it's doing something. Generated all the dots. I've got a feeling this isn't right. One second, let me scroll up a little bit. Yeah. Why? Oh, did I never draw the layers? Ha! I bet you that's what I did. Okay, let me go down to the main. I never drew layers. My bad. Okay, so we have animation draw frames. Now let's do draw layers. And we want to read in layer. Add in a semicolon right here. Go over to make one more time. And let's see what happens. It seems to generate all the frames. Let's go to Mirage image and let's scroll down. They are all completely black. Well, good. That's something. Let me go here. Let me run in Mirage frame animation is what I want. .gif. Okay, so this is what we have so far still. Haven't gotten any further than this. The layers are all black. Don't know why they're all black, but they're totally all black. So, let's think. Why would they be all black? Not sure. So let's scroll up to the top. And I'm going to try something. I'm going to go through and let's see. So we drew, one second. Where are we? We drew, here's main, while, node Q, here. So we drew all the external on layer 1, and we drew all the internal on layer 2. Then we did the draw layer function, which should go through each of the layers and write them all to the PNG base, right? So let me try going through and not drawing the background layer. Let me just try drawing from j equals 1, here. Let's go there. And let's see what happens if we make this one. Oop, that was not what I meant to do. Make this one. It should still go through, except this time we don't have a background layer. So let's see what happens if we do this. They are all still black, which is good in a way, I suppose. Okay, so draw layer. String PNG ID number. Let me run this guy. Good. String PNG ID number, that's fine. So we go through and we say for size T j equals 1, rather, for size T I equals 0, I less than number of frames, total number of frames we're working with, for size T j equals 1, j less than layer dot size plus plus j. Okay, so unless I'm mistaken here, we should totally be drawing to each of the frames, like each of the, I suppose, frame classes or structs or whatever I used for layer 1 and layer 2. And for some reason, this isn't doing exactly what I thought it would do. So let's see, layer of J, frame context of I. So we're kind of painting layer of J, frame context of I. So what we're doing, we're setting the sources, set source surface, and then we're painting it. Okay? Now we're going down here, and we're saying Cairo right to PNG, layer of 0, frame surface of I, which should be the one that we're writing to. We are getting the appropriate PNGs. That's fine. Like, the numbers are correct and everything. So we're kind of sort of getting there. Cairo set source surface. Maybe. Maybe nothing is actually written to these guys. Let me go up to the top. Let me go down here. And let me think. Layer 2. Draw external, draw internal. Animation. Let's see. Frame, animation. So what do we want? Draw internal. Draw external. They're both, or rather they both should be returning back the frames that they're working with. Okay, Huffman tree should be just fine. Okay, so let's see, what do we have here? Draw layers, depth for a search, draw internal. It all seems like it should be okay. So I'm gonna get a quick sip of water. If you have any questions, let me know. Man, we did a leg day the other day for working out, and I can't get over it. My legs are killing me. Like, I went to bed super early last night, and then like this morning I wake up and I just cannot move my legs. And the problem is, because of the way I sleep, I have like this little couch that's like right next to my computer, so I can't exactly roll off my bed. And so like in order to get up, it was a lot of pain. That's okay. Do you code with the console? No, I code with the terminal. I think a console is something else. Like you play games on that or something. Okay, so let's see. Command line, I guess, is okay. Is it called a console? I don't know. I thought console was for Windows. I'm not sure, but definitely code with the terminal. Yeah. Okay, so what do we have? Animation, create frame, 400, 310, frame, image. Not sure what the deal is here. So let's go through and let's take a look. There could be a couple of problems here. One problem could be in draw internal and draw external. However, because we're reading in the struct that is frame, I have a feeling that these guys should be fine. Draw internal and draw external. My fear is that we're actually having trouble with draw layers. So this is what I want to do. Instead of drawing layers down here in main, what I want to do is draw just one individual. Here, animation, draw frames. No, what I want to do is go down here. Grow a circle. Oh, okay. And let's do this. Comment this guy out. And let me do layers. Layer of, let's say, 1. Draw frames. Right, this, go over here. And let's do this. Let's do make. And let's see what we got. We are generating all the frames. And let's see what it looks like. Mirage animation.gif. I'll get to your question in just a second, Dr. Skilled. Okay. Oops. This isn't helping any. Let me do frames, image. 00, why not? All zeros. That PNG. Okay, so it looks like we're generating a whole bunch of images. That's good. Yeah, okay, so we can officially draw one layer. No big deal. Okay, that's perfectly fine. Let's see. So, Dr. Skilled, first question. Why do you code without an IDE? The reason I code without an IDE is because I'm often SSH'd onto other people's machines, and honestly, by other people's machines, I mean like a computing cluster or something somewhere. I do a lot of my programming on the computer cluster here in at OIST. And the thing is, it's not exactly good practice to open up a graphical interface to do programming if you're SSH'd onto a cluster like that. Now, granted, you could open up a node and you could do that, but because I do GPU computing, it ends up being that opening up a node on the GPU cluster is just to do like an IDE or something like that isn't exactly, in my opinion, good practice. And so because I'm kind of hogging up a node anyway, I kind of prefer to keep it as minimal as possible. Plus, using graphical interfaces while you're SSH onto other machines is finicky at best because you have to deal with network latency and stuff like that. The other reason is this is how I learned to code. I prefer coding with VI. Vim is actually a little bit too far for me. I have to set compatibility to really work well with Vim. It's just how I code. Other people can code in a whole bunch of different ways, and that's fine. For me personally, this is just how I do it. So, yeah, I guess that's about it. There aren't really any big, deep personal reasons to it. I don't like syntax highlighting because it makes it hard for me to read the code. And I don't use IDEs because for work I can't use IDEs, so why learn how to use an IDE if you can't use it? So that's kind of the idea. Plus, honestly, the command line is way more user-friendly, in my opinion. Like, by that I mean you can do a lot more stuff with the command line than you can with an IDE, you know? So you can manipulate your make-file, which I guess you can do with an IDE too. Maybe that's not true. There are probably a whole bunch of ways to do cool things with IDEs. I just don't know how to do it. So that's kind of the thing. Okay, so let's go here and let's see. What do we want to do? So what we just showed, I don't know if you guys saw that or not. If we go through all these images, we have generated all the dots, but we have not generated all the lines. So let's do it one more time. Let's go to layer of 2, which is where we drew all the lines, .draw frames. Okay. And let's go here, write this, and let's go to make one more time. And now what we're going to do is do the same thing we did before. And just to make sure, oh, interesting. Wow, that's super interesting. So let me do, I know what the problem is. Yeah, got it. Okay, so now watch this. Mirage image .png. Now we are not drawing any of the dots. We're just drawing the lines. Now I know what you think, what you're thinking. This is stupid, right? But this actually is super interesting because now we know what the problem is. The problem is that after drawing external, I never set the following. So we're going to say layer of 2.currentFrame equals layer of 1.currentFrame. Okay. So now after that, let's go here and let's try making it one more time. Now it should be that we draw the same image we could draw before, or not. I screwed something up. Let me see. We're still screwing this up somehow. Let me go here. Let me write layer 2.currentFrame. Let's see. Make it one more time. Maybe I forgot to write. No. Okay. So I clearly am screwing something up here. Image, draw frames. Oh, I'm redrawing the frames. Ah, great. Okay, so that makes sense then. I'm drawing the frames over the other frames. But just to be safe, let me go ahead and go into this. Yeah, so you'll see it's completely black until frame about 80 or something like that, and then we draw all of these things. It's waiting until about frame 80 because we were supposed to be drawing all the green dots. However, I wrote over all of the green dots on accident. So we're kind of getting there. Now, what's the next step? Well, the next step is figuring out how to do this draw layers command. So let's go here. Let's do this. Let's write this and let's make this. Okay, 1 second. Now we're going to do Mirage image. And obviously the whole thing is black. Now, why it's black is not exactly obvious to me, and I'm not sure exactly why. So what we're doing in the draw layers command is we're going through all of the different layers, right? Or rather all of the different frames. So let's say we have 300 frames in this particular animation. We're going through all of those frames. Then in each of those frames, we're going through and we're drawing one layer in particular. And then we're putting another layer onto the same surface. So what I want to try to do is I want to try to do this without this loop. So let me see what happens if I go here. 1 second. And I just... Oh, my bad. Screwed up that last one. So let me do the following. We're going to copy these lines. So Cairo, set, source, surface. Then what do we want? We want layer of 1 dot frame context. Context of I. Then we want the next one, which is layer of 0. 1 second. Layer of 0 dot frame surface of I. And again, layer of 0 is our background. So then we do 0, 0. That is the X and Y shift. And we don't want those here. Now we do Cairo paint. And we paint the surface. So we want layer of 1 dot frame context of I. What did I do there? Frame context of I. Okay. Now let's see what happens. If we write this, we go down here and we run make. Error. Cairo set source. Of course, I misspelled source. That's okay. Make. Give it a second to do the making, and then we'll take a look at it afterwards. It's probably going to be all black again, and that's okay. It is indeed all black again. So now we have to figure out why it's all black. And that is not exactly obvious. So let me go here. Cairo paint layer 1 frame context. Before we were doing layer of J frame context. Let's see, vector frame layer. How is this any different than what we had before? So before we were doing the following. Let me see. Grow circle, frame, create frame, draw frames. So we said we're going through the number of frames. We say Cairo set source surface frame context. It's fine, we're doing the same thing. Frame surface. Maybe that's it. So let me go up to the surface. We are defining the surface. Oh, no, that shouldn't be a problem. All we're doing is defining the surface. With a certain number of frames. Darn. Okay, so let's go down to frame. Okay, let's see what we got. Frame init, frame draw frames. This is what we want. So we are generating the appropriate number of frames to go with. So let me try a couple different things. So let's go down here to the bottom. Instead of using layer 0, let's try layer 1. Go down here, try layer of 1. Go here to make. Let's see what we got. Can't tell from here. Okay, so now we're generating all the different points. So let's try another thing. Let's try this. And let's try layer of Cairo paint layer of, what do we want? Frame context. So let's try layer of 2. And let's go down here, try layer of 2. Mirage, what do I want? Make. Okay. Mirage image. This one does not work. Oh, interesting. What is this doing? Huh. Okay, well that's interesting. Okay. So this is something I wasn't quite expecting. Let me change this back to layer of 1. And let me change this to layer... Yeah, let's see what happens. Make. And let's see what happens. Mirage image. Nothing, 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 nothing. However, we do draw that at the end. Let me remove all the images. Remove frames. Image. Star. Okay, now let's try drawing it again. Make. Make clean. Make. Give it a second to do its thing, and then we should be good to go from there. So here are all the images. Let's go into the last Mirage. Yes, okay, so it's still drawing all this. So let's change this to layer 1 again, and let's make it again. Okay, so now we have all the points drawn, but I doubt we have the lines. We do not have the lines. Okay, so I'm kind of seeing what the problem is here. Here we have 3 layers. We have a black background layer, then we have an additional layer for all of the green dots, an additional layer for all of the white lines. And the problem is, the way that we're currently drawing this, we are either drawing all of the green dots or all of the white lines. And I'm not sure how to make it so we draw the green dots and then the white lines under the green dots. So what we need to do is first draw the white lines. No, we have all the different layers. What are we trying to do here? We're trying to put all the layers onto a single surface. And then we're trying to draw that one surface, right? So what I'd like to do is the Chiros set surface. Oh, you know what might be a problem? I bet you I know what might be a problem. Let me go up to the top here. Let me see. Where are we? When we do the init, initially, let's see, RGB, int R, int G, int B. Okay, so let me go down to the init command. So let me do frame, init. One second. Init, here we are. We read in an RGB. I'm not going to initialize anything but the original frame. So let me go up to main. And what I do is when I initialize all the frames, I have this init command here. What I'm going to do this time is I'm going to comment that out. And I'm going to go down here and say layer of 0 dot init with 0, 0, 0. Let's go here and let's do make. Now this should mean that all of the other images... Oh, segmentation fault. Fantastic. Okay. Let me see. Why would this be an issue? Layer of I init. Layer of I current frame. Huh. Okay, so let's see. Let's just see out something here. std see out generated background. Gosh, I can't spell. Okay, let's go here. Background with AD. I need to add an additional guy here. Good. Write this, go over here to make, and let's see what we got. So we didn't get quite to the point where we generated the background. Let me go here and let me do std see out I and line. Make. Error, of course. Make. Okay, so we are not getting anywhere. Let me do this again. Make. Yeah, this one seems to work okay. Why does this one seem to work? Interesting. Okay, so let's go down. I think the issue... Let me go into init. Frame. Here. Init. Okay, so we say line width is equal to 3. Okay, so this is where we kind of initialize everything, right? So where's RGB? Chiros set source RGB. Okay. Now what do? We do this Chiros rectangle thing. I'm not going to do this Chiros rectangle thing. Okay. So I'm going to go up to the top. Main. I'm going to remove this guy down here. Remove this guy right here. Write this, go down here, make it. And hopefully we don't break it. Okay, seems promising. Image. All of them, all the dots are being created. All of the lines are not being created. Shoot. Okay, so let's go down to the bottom again. And let's see what we got. So before they were all black. Which is fine. Let me see what happens if we draw this to layer 2. Frame surface here. 2. And layer 2. Let's do make. Okay, now let's see what happens if we do animation. Scroll down a little bit. Obviously nothing until we get there. Dang. I was really expecting that one to work. Okay, so now what else can we do? Let me see if this for loop works all of a sudden. So let's go here. Those were question marks. Okay, so let's there. Cairo paint, don't need that one. And let's change this to a layer of 0. And let's make it one more time. Yeah, that one didn't work. Yeah, it totally didn't work. Okay, so this is where I'm kind of getting confused. I'm not sure exactly what to do in this situation because we have a whole bunch of basically clear layers. And I'm trying to draw one layer on top of the other layer, but for some reason it doesn't seem to be working. So let me go back to what we did before with the subroutine webcomic stuff. Hopefully that'll work out okay. And again, guys, if you want to look into this code, I'm just going to show you where it is. Here's my channel. Scroll down real quick to info. Go to github.com. There at the bottom. And go to Simuleos and Huffman. Here we are. And then it'll be under Huffman visualization.cpp. And that is what we're currently working on. So let's go back down here. Okay. Cairo, right to surface, right to PNG. Let me go over here because we've kind of done something like this before. And again, I showed it earlier in stream, so I'm not so worried about it. But let me go here and let me VI, let's see, subroutine.cpp. And we should have right, where are we? Right text? No, where is it? Right image. Sorry about that. Right image. Good. Okay. So what we did is we went through all the different panels, which in our case over in the other, in the Huffman is going to be all the different layers. And then we said, Cairo set source surface, background context. Okay. Then we do comic panel surface I, comic X position, comic Y position. Okay, so those are both going to be zeros. Panel surface of I, comic background context. Cairo paint, comic background context. Cairo surface right to PNG. Okay, so this is actually a little bit different here. So we do comic background context, comic panel surface. Okay, so we have whatever we want to draw. Then we do comic background context. Let me see. And then we write the entire surface. Okay, so let's see. How does this compare to what we do over here? So let's go into VI Huffman visualization.cpp. Go down to the bottom and let's see, what do we do? So here we go through each of the number of frames. That's fine. Then we go through each of the layers and we say Cairo set source surface, layer, frame context of I, layer 0 frame surface. Okay, so let's try changing this. Let's do layer of J, frame surface of I, and then layer of 0, frame context. So we're writing this onto the background context. Now we do Cairo paint, layer of I, or layer of 0, frame context of I. Okay, now when we go down here, we're going to try, what do I want to try? Comic background surface. So let's do layer of 0, frame surface of I. I think this should be right, so let's try making this. Let's see what happens. Well, it might have worked. Let's go into Mirage. Oh, look at that. We have all the dots. And we have all the lines. Fantastic. Yeah. Okay, good. So we have all the dots, all the lines. Everything seems to be okay-ish. That's great. Okay. So now, we just have to figure out how to draw the lines underneath the dots. Boom. Okay. We're getting there. Totally getting there. I think. Okay, so let's go here. Let's go ahead and quit this. And let's see what we need to do. So what we need to do is set the background to black, which we can do in just a second. That's not a big deal at all. Visualization.cpp. Luckily, we are getting somewhere. So let's go open up the images. We have all of these dots being created with all the letters on them. Now, let's see if we can get these lines underneath. So let's go down to the bottom. My question is why they aren't underneath to begin with, and that's not obvious to me. Because we're going through all the different layers. Oh, we're starting with 1. What happens if we start with 0? Does that change anything? I feel like it shouldn't change anything. Let's go here. Let's go to make. Because the background image in this case is just a blank slide. Yeah, so it doesn't change anything. Okay. So I think what I need to do is actually go backwards. Okay? So I want to draw the other way. So we're going to say I equals... no, we still want this to be 0. Sorry about that. I equals layer.size. Size. J is greater than... Oh, has to be a J. My bad. J is greater than 0. Oh, what am I doing with my life? 0. And then we're going to do minus minus J. Let's go over here. Let's do make. Layers.size. I forgot parentheses. Make. And let's see what we got. Okay, so it didn't like that. Let's see what's happening in here. So let's do std cout j and line. Ah, gosh. 1 second, I need a semicolon. Let me go over here, add in a space, write this, go over here to make, and let's see what happens. It looks like we got 321 frame image 00.png. We get to 3. It doesn't seem to like that. That's because we don't have a 3. Let's try this. Make. Okay, I'm not sure what this is. At all. No idea. 210. Make. Okay, it seems to be doing something. Let's go into Mirage Frames image. We have all the dots being created and all the lines are being created underneath. Fantastic. Yeah. Totally got there. Okay, so now the last thing we need to do is set the background layer to black. And then we will have everything done that I wanted to get done today with 20 minutes to spare. So we can start working on what we need to do tomorrow. And I realized today was kind of drudging along. My apologies. That happens. Okay. So what are we going to do? Let's go through and make that background black. Okay. So let me go up here. We are initially reading in a color. Let me see, to the frame init. So let me go to frame init. Nope, not that one. Not that one. That one. Okay. Now, where does this color actually come into play? It only, I think, comes into play in setting the background color, right? So let me see. Cairo set source RGB. Yes. So that's the only place it comes into play. So what I'm going to do is I'm going to create another function here, and it's going to be void create background. And for this one, I'm going to read in RGB here. And then I'm also going to read in the frame in which we want to work with. So let's do frame in RG and B. Okay. Now what are we going to do? We are going to say the following. We're reading in a frame. So I'm going to call this frame anim, just because I'm clever. And now I'm going to say the following. I want to do Cairo set source RGB. Yep, that guy there. Hey Zippo, thanks for coming back. Now we want to do the following, which is Cairo rectangle, and then Cairo fill. So I'm just going to copy these 2 lines. Okay, and now of course I need an ampersand here. Ampersand. Okay, now what else do we need? Cairo fill, and then I think that's all we need to do. Background surface, Cairo image surface create, Cairo create background surface. All right, I think that's good. Create background. Let's go here and creating basic colored background. And yeah, let's see if this works. I've got a feeling it's not going to, but that's perfectly okay. So now what we can do is go ahead and get rid of these guys here, and we can make init not require any functions. So let's go to init and let's see where we use it. Init here, init there, init there, and in fact we can delete these lines. And next, init here. And what else do we have? Init. Hey, Love Feelings, it's going fantastically. Thanks for asking. Let's see, initial variables, good. Where's init? Good. Okay, so now all we have to do is put this here, up at the top. Let's go up to the very top, scroll down a little bit, put it, I don't know where I want to put it. Let's put it up here. Why not? Function to create basic colored background. Okay, so let's put a semicolon here and let's make it make. All the television in my country got crazy because of the Turkey revolution that's happening at the moment, and now my whole country is scared of World War III, considering the France massacre that happened 2 days ago. Yeah, Japan's fine, in a way. That's where I'm at. I don't know. The US is falling. Yeah, we got the white lines behind. In fact, let's just go ahead and make it. Okay. We got a whole bunch of issues here. Let's go ahead and fix all those issues. 177. What's the issue? Cairo set source RGB. Oh, obviously we don't have frame context. This is animation. Animation dot frame context. Go down here, animation, frame context, and animation dot frame context. Write this, go over here to make. Let's see what's next. Frame context of eye is obviously not a thing, so 1 second. Here's what we're gonna do. For int I equals 0, I less than number of frames. How did I do that one? Number of frames. Then we do plus plus I, and we go down here and there. I. Okay. Resolution X is not declared in the scope. That's because these are both anim.resolution X and anim.resolution Y. And anim. Okay, let me go here, right, make. Nim was not declared in the scope. Fair enough. Make. Okay, give it a second. We're generating all the images. Seems fine to me. Let's do Mirage image 00.png. And everything seems fine. Good. So we have all the white lines underneath the green dots. That's perfectly okay. Now, what is the next step? Let me see. While you have it, let me see. While you have it, I'm tired. Might not. Wait. While you have it less than. I don't think it really matters that much, less than or equals to. It just depends on where you want to go to. I mean, this is fine. I haven't run into any problems with this before, but maybe I will in the future. Okay, so now last thing I need to do is create background, and I need to do that up here in main. So where are we? We are in, here. So let's go here, and let me do create background. And what I want to do is put it on layer 0. If I can put a 0 in and do this correctly. And I want it to be of color 0, 0, 0, 0. Now let's go to the following. Make, here, a Gothic Death Eater. What flavor is this? Do you mean of Linux? It is Arch Linux, and I think I just screwed this up. No? Oh, it looks like it's working. Booyah. Okay, I'm using Arch Linux, and if you're asking for desktop manager or desktop environment, I'm actually using OpenBox. So what do we do? Let me go ahead and remove this SDDC out. Let me go into the Makefile, and let's see what we got. So what I want to do is now convert it to a, now convert it to a graphics interchange format file. Write this, go over here, and let's do one more make. Give it a second to make all the images, and then combine them all into PNG files or into a GIF image, and then we'll be good to go from there. 1 second. Okay, so now let's run Mirage, animation, frames, animation.gif, and here we have all the points being created and all the lines being created underneath, and that's exactly what I want to see. Arch is pretty much totally blank from the install. So after the installation, you have you don't even have a graphical user interface. You have to start from there. But yeah, as Zivo said, it's totally customizable, which makes it really nice. I've been running with this same setup for the past, I don't know, 7 years, since junior high, basically. Let's see, I'm 24 now, 14 then, so 10 years almost. I've been running with the same setup, basically. Subtle changes here and there, but basically the same guy. I actually created my own custom OpenBox format here that uses just white, gray, and black, so that I could very easily tell, the difference in colors and things like that. I'm actually very happy. I couldn't be happier with this setup. I have my own keybinds, everything works well, and I'm happy with that. So, however, I'm not pushing Arch on anyone. I'm not one of those people that believe you should, definitely use Arch, and if you're not using Arch, you should, consider a different career path or something like that. It's fine. I think any distribution you want to work with is fine. It sounds like a pain in the ass. Oh, sorry, I accidentally cursed on stream. My apologies. But I was thinking of giving it a crack. I'm using Mint. So here's the thing. I learned a lot about how Arch works underneath from doing the Arch installation. I learned a lot about Linux doing the Arch installation, but then again, when I did Linux for the first time, I knew absolutely nothing. I was a complete and total novice to everything that had to do with Linux. In fact, I didn't know what the terminal was, and I didn't know how to write things to a disk. I knew nothing. I was a complete and total noob. That said, I learned a lot, and after doing the Arch installation, I really felt like I understood what my computer was doing. And it's good. That's why I use it. Use Arch for like a year. It's worth the beginning pain because it's simple in time, and you get it to love it when you start customizing it. I know, I try to keep the stream family friendly, and I really do apologize for anyone who may have been uncomfortable for me accidentally swearing on stream. Okay, so what do we need to do here? We've got a few more things left to do with this particular image. First thing first, which you might notice, is that the letters don't look that good on each of the little dots. We have to fix that. We also fix the exposition of all these dots, which is going to be a pain in the butt too. But it's not going to be that big of a deal. Now that we have the different layers and everything set up, I think this will be relatively simple. We just have to kind of, move one step at a time. So to me, what we need to do for the rest of the day, because we only really have 15 minutes left, let's see. Let me think. Look, the way I see it, I really like Arch. A lot of people really, really like Arch, and that's fine. You can see that the community for the people that use Arch is incredibly user-friendly. Well, kind of. In my opinion, it's incredibly user-friendly. However, in my personal opinion, I do think that some people who use Arch get really high and mighty. They think to themselves that because they're using Arch, they're somehow better than everyone else, and that is completely wrong. It cannot be more wrong. Arch does not mean you're good at anything. It just means that you enjoy simple things. You enjoy simple operating systems. You enjoy starting things out from scratch, building it all yourself. That's what it means. It doesn't at all mean that you are somehow better at Linux than other people, because that's not true. However, they have the best wiki. The Arch Wiki is fantastic and has so much information. Let me see. Now, unfortunately, I've used Windows 10 since I developed pretty much for Windows. Unreal Engine 4 requires Windows, so yeah, I'm kind of... Yeah, maybe there is a beta version for Unreal Engine. I have no idea. I don't use so much with graphical anything, as you can see here, for me failing miserably at graphical processing for the past few minutes. I guess while you guys are here, I might as well say this. I'm going to go ahead and clean up the code a little bit for the next 15 minutes. Just kind of add in comments, remove things that are unnecessary, things like that. So I realize this is going to be kind of boring, so feel free to talk about whatever it is you want to talk about in your in the chat. That's perfectly fine. So we don't need these anymore. We can delete these guys here. And let's go up. And while we're here and we have a little bit of free time, feel free to ask me any questions you have about literally anything. Again, I'm a physicist by trade, so it could be anything related to physics or anything else. Okay, so we no longer need to redraw the circles. This is good because we now have layers, and layers are beautiful. So let's go ahead and remove all those. Now let's go up here. And what else we need to do? See what else we need to do. These guys right here. Let me see. It did, but it works on slow and bigger projects. Oh, I've got a 970 on this machine, but I don't use it. Literally, when I started making my computer, let's see, what was I going to do? I was going to make my computer, and I asked my friend what graphics processing unit I should get, and he said, oh, get a 970. I was like, oh, I trust you. I'll get a 970. I haven't used a 970. I don't need a 970. Okay, so let's go here. We no longer need this for debugging, so let's go ahead and get rid of this. Everything seems fine there. And let's go down here. While regenerated nodes, yes, so this is just printing out the regenerated nodes. Those are no longer necessary. Okay, layer 1, draw frames. Layer 2, those are no longer necessary. Let's see. What would be the best to practice an algorithm in your opinion? Like, when you get to learn and understand a new algorithm, where do you begin? I'm a physicist by trade. So I gotta admit, I love reading papers. So I always start with the basics, which is reading the paper. So for example, not too long ago, when we were starting up with, let's see, we did Lanzau's algorithm and decomposition, QR decomposition, stuff like that. I have, let's see, 3 or 4 papers right here related to QR decomposition and the Lanzau's algorithm, just literally right here on my desk, you know? I Google it, I look it up, I read it. That's what I do. And to learn the algorithm, well, you know, there are probably some good books out there, good resources to learn the algorithms with. It's just a matter of Google searching and going from there. If both are NVIDIA cards, that might hint at a driver issue. Yeah, maybe. 970 in the case if you ever want to play some games. The thing is, I don't ever play any games. Like, the most graphically intensive game I've played on this computer is Don't Starve. Oh, I'll take that back. I play Guild Wars 2. I do play Guild Wars 2. That's fair. Let me see. Zivo 25 didn't run so much tests. The project was kind of big. Yeah. Fair enough. Let me see. I don't have a good GPU on my laptop, but the open source drivers for the Intel integrated graphics are, I think they're okay. The Intel, they're okay. What language are you using again? I'm using, yeah, it is C++. Intel graphics. Yeah, good. Everyone knows it's C++. Fantastic. Okay, so let's go through and remove all the unnecessary comments and check to make sure all of this makes sense. And we'll kind of work through the logic of this guy one last time, just to make sure it's okay. So what we've done here is we have created 3 different layers. A background layer, which is black, a middle layer, which is all of the white lines that you'll see in a second. There they are. And all of the green dots are the external layer at the end. And the idea is that we kind of draw each layer individually, right? And then we kind of concatenate them at the end. And it seems that this has worked perfectly well, which is great because now we can implement layers in all of our future work, which is great. Now, we have a lot left to do, and that's fine. But we'll kind of get to that as we get to it. Tomorrow, what we're going to do is find a new, I guess, positioning scheme for all of the leaves, hopefully to make it so that we can draw all the leaves in a good position to make it more visually appealing to draw, if that makes sense. Okay, so I think I've removed all the unnecessary comments here, all the ones that I could see anyway. Let me see. Oh, this probably should be removed. Now, what was I doing here? For animation current frame, set source RGB. I think I can remove this. I see no reason not to have that in there. Animation current frame. Good. Okay, so now at this point, I think I can go ahead and commit it to GitHub. 1 second. Yes, so it looks like it's good enough to commit to GitHub. So let's go ahead and right quit. Then we're going to do git add. Actually, let me run a quick git status dot. Yes, so the only thing we modified is Huffman visualization. Let's do git add Huffman visualization dot cpp. Then we're going to do git commit. And what do I want? Just git commit. Now you'll note that this directory is really messy. I apologize for that. That's okay. So we're going to say added in layers for animation. Now, need to reposition leaves. Right quit, git push, origin master. Yeah, feel free. Wouldn't there be a zero end problem at some point? Struggling to... let me see, what do we have here? Gothic Death Eater. Looks like C++ to me. Is it scalable with this? It's okay. I don't know what you mean by scalable exactly with this particular part. I don't know what part you're talking about. So if you want to get to the GitHub repository, simply go to my stream, go to the info section, scroll down, click on the GitHub link, which I already have right here. And then you should be brought to my GitHub directory. So let's go back a little bit. Here, go to Simuleos. Simuleos is huge, for the record, guys. This is where I keep everything. It's going to be under Huffman and Huffman visualization.cpp. Feel free to run this yourself. You should be able to run just the make command, and it should make the animation. And while we're here, I might as well take a step back and talk about what we did yesterday, which was work on the visualization of determinants, which I thought turned out really cool. So let me show you guys that too while you're at it, while we're at it, and we'll kind of go from there. Let me see. I don't know how scalable it is, Gothic Death Eater. I really don't. Herioctura, let me see. The only problem I have with installing Arch on my PC might be the internet connection. I use a TP-Link wireless USB dongle as I'm missing a LAN connection near my workstation. I think wireless is fine. It depends. Okay, so while you guys are here, let me just go ahead and CD back a couple directories, and let me kind of explain what we're doing here, because I don't see very much more we can do in 10 minutes. So let's go ahead and CD back, let me see, to visualization and determinant. Let me run the following: mplayer out.mp4 vox11, so you guys can see it, and then loop 0. So this is what we did yesterday, guys. And what I wanted to point out is this stuff that we did yesterday will be available soon. So basically what we do, this is some of we visualize a determinant. And a lot of you guys know a determinant from math. And I think that's really, really cool, what a determinant is. It's actually a ratio between the volumes at the end. So what we did is we did a transformation on a box, right? We put in the original box in an exterior box. And then we performed a Monte Carlo algorithm, which will look a little bit better in the end, to find the difference between the volumes. This stuff will be up on my YouTube channel on July 24th, I believe. So if you're interested, feel free to take a look at that kind of stuff. We did this again yesterday. The point is, this directory has a whole bunch of stuff in it. And so if you clone it, it might be rather large, and I apologize for that. We need to clean it up at some point. But that's, I guess, about it. I don't really know what else to say. We can talk about what we need to get done. But I don't really see so much left to do there. So let's see. We can, at this point in time, the Huffman visualization that we did today, once it's completely done, will be up on my YouTube channel, like, I guess 3 weeks from now. Next week will be the determinant stuff. For the rest of today, I'm going to spend most of my time recording my next YouTube video, which should be a good bit of fun. It's again on the determinant visualization and stuff like that. I guess that's it. So I might end today's stream a little bit early, guys, and I'll be back tomorrow for the next episode of Simuleos, where we continue working on the Huffman tree, this time creating a new position for each of the individual elements And if you guys are interested, feel free to follow me on YouTube, which is here. LeosOS is the name of the channel. It's, I think, a lot of fun to do. Thanks so much for watching. I guess that's about it. So I apologize for the awkward ending and ending a little bit early today, but we finished everything we needed to do, and I see no reason to stay here any longer. So guys, have a fantastic day, night, afternoon, morning, evening, whatever time it happens to be your time, and I will see you guys around next time for the next episode of Simuleos, where we hopefully finish up the visualization of simple Huffman trees. That's where we're going with this. And that's about it. So, see you next time, guys. Yeah. Bye, guys.